The question says write the coordination number and oxidation state of platinum in the complex. Platinum is the central metal atom. This is the complex given here. First we calculate coordination number, and always keep in mind coordination number is the number of ligands attached to the central metal atom. Okay, so the complex we have platinum is there, and this is what En, ethylene diamine. En is the ethylene diamine, and then we have Cl2 is there. Okay, before calculating coordination number, always identify we have unidentate ligands or polydentate ligands, because in that case coordination number will change. Okay, ethylene diamine, the chemical formula we have, it is NH2 and it is CH2. We have CH2 and this is NH2 is there. Each nitrogen is having one lone pair. Okay, so how many total number of lone pair? 2 are there. So it can form how many bond? 2 bond. One ethylene diamine can form 2 coordinate bond with the central metal atom. Let's say platinum is here, it can donate electron density, it can also donate electron density. Okay, so one ethylene, this is what a didentate neutral ligand, because it is forming 2 bonds, 2 coordinate bond. So one ethylene diamine is forming 2 bond. There are 2 ethylene diamine. The total number of bonds formed by ethylene diamine will be 4. 2 to the 4. Okay, 4. And this is what a unidentate negative ligand. Each chloride ion is forming one coordinate bond. There are 2 chloride ions. So 4 plus 2 is equal to 6. Then we got a coordination number is what? 6. Okay, this is octahedral complex. From here we got this is what a didentate neutral ligands. So each ethylene diamine is forming what? 2 bond. 2 are there, then total number of bonds will be 4. 4 plus 2 is equal to 6. 6 bonds are being formed with the central metal atom, hence coordination number are 6. One way also we can say coordination number is nothing but the number of bonds formed by the ligands with the central metal atom. That is more clear, I think. Again, number of coordinate bond formed by the ligands with the central metal atom. It is quite a precise statement. Okay, now we calculate oxidation number. Okay, when we calculate the oxidation number of the central metal atom, you should be aware about whether we have negative ligand or neutral ligands. In case of neutral ligands, oxidation number, the overall charge will be 0. Okay, so we have common rule we can use. We have platinum is there, which we will learn in oxidation rule. Okay, platinum plus ethylene diamine, it is a neutral ligand, it does not carry any charge. 2 multiplied by it has 0 charge. Okay, and then we have chloride ion. Each chloride ion is having -1 charge. This is a neutral complex, is equal to 0. Total charge should be 0. Okay, we have platinum, it is 0, it is -2, is equal to 0. Platinum minus, we can write -2 is equal to 0. From here we get a platinum is equal to +2. Platinum is present in +2 oxidation number in the given complex. It is present in +2 oxidation number. If you like this video, please share and subscribe to the channel.